Okay, today's lesson is lesson 8.2, and it's on zero and negative exponents. So one of the first things that you need to know is that any base, let's call my base A, to the 0 power is going to be 1, always. So if you have, say, 4 to the 0 from the flow calculator. Another thing that you might think is interesting is when you have 1 over 100, or any fraction for that matter, if you take it to the 0 power, it's always going to be 1. Now the exceptions to this, I know I said always, but there are exceptions sometimes. Like when you have the opposite of x. Sorry, I had to pause. So if you have the opposite of x to the 0 is only applied to the x. It is not applied to the negative sign. So this is like a little negative 1 in front. So this would be negative 1 times 1, which is negative 1. Additionally, if you had negative 2, but it was in parentheses and it was raised to the 0 power, in that case, the 0 power is applied to the negative with the 2, so it would be a positive 1. But if you had negative 2 to the 0 power without parentheses, that would simply be negative 1. Because like I said before, the 0 is only applied to the 2. The other piece of information that you need to know before we start doing practice problems is that when you have a base to a negative exponent, you're not allowed to leave it as a negative exponent in your answer. So you would need to write this as 1 over a to the positive n. You can even think of it as this little negative bar becoming this bar right here. That's how you make your exponent of n positive, and you have to put a 1 on top, unless there's something else already there. So let's try this. Let's say we've got 3 to the negative second. You have to make that to a positive 2. So the way you do it is you put 1 over 3 to the second. And you are expected to multiply it out. So that would be 1 over 3 squared is 9. So 1/9. Okay. Now if you have a problem that's like this, 1 over negative 5 in parentheses to the negative second, anytime you have a negative exponent, you need to change its position within the fraction. Well, let's write that down. Negative exponent need to change its position in the fraction. So this one, you need to make this a positive 2. You would put this over 1 because your negative 5 is going to go up to the top and be raised to the positive 2. You're just going to flip it. You're kind of taking this, bringing it up here, this, bringing it down here. Now, you can't leave it like that, and I definitely don't want your answers over 1. But you take the negative 5 and you square it, and that's going to be negative 5 times negative 5, which is positive 25. Alright, so let's do some practice problems. Let's say we've got negative 9 in parentheses raised to the negative second power. Now let's say we've got 1 over 27, and that 27 in the bottom is raised to the negative first. If you were going to make these positive exponents and then go ahead and multiply things out, then this one is going to need to make a fraction. You're going to put 1 on top over negative 9 in parentheses. It's raised to the positive second power when you take it down to the bottom. And that's going to be 1 over negative 9 times negative 9, which is positive 81. So it would be 1 over 81. Do this one by yourself. Just so you know, when you bring this up to the top, you don't have to write it as to the first power because anything is already implied to be to that 1. So this would just be 27. Let's evaluate 6 to the negative 4th times 6 to the 4th. Now they have the same base. So anytime you have the same base, what do? You add the exponents. So this is going to be 6 to the negative 4 plus 4, which is 6 to the 0, or just 1. Alright, let's try this one. 2 to the negative 3rd to the negative 2nd. I'll give you a couple of example problems to write down. Okay, so let's practice with these. This first example right here, the 2 raised to the negative third, and all of that is raised to the negative second, we call that a power to a power. You've heard me say that in class. And anytime you have a power to a power, you're going to multiply the exponents. So multiply the exponents. So when you multiply your negative 3 and your negative 2, you get positive 6. And then because it's a power of 2 and it's not to a very large number, I'd expect you to multiply that out. You know that 2 to the third is 8, so you can start there. And then you can multiply 8 times 2 3 more times. So 8 times 2 would be 16, times 2 would be 32, times this 2 would be 64. And then erase this. And we'll just put 64, but you'll need to have the work. Okay, on the next one, you've got 2 items in parentheses, and you can actually multiply them together right away. So if you multiply those 2 items together, you get negative 6 to the negative second power. You cannot give me an answer with a negative exponent ever, so you need to write this as 1 over negative 6 in parentheses squared. Just the negative 6 is squared technically, and this would be 1 over 36. Okay, on the next one, we've got 4 to the second times 4 to the negative third, that's a negative 3. This is a situation where you would not multiply the exponents. You have to recognize they each have the same base, and the same base they have is 4. When they have the same base, write that down. You do what to the exponents? You add them. Same base, you add the exponents. So what we're dealing with here is just a 4. You do not want to multiply your 4's together and make it 16 to a power. It's just 4 to a power. And it's 2 plus negative 3, which would just be 4 to the negative first. That cannot be your answer. You have to make it a positive power, or have no power in this case. So you would just put 1 over 4. You could put 1 over 4 to the first, but I would rather just see 1 over 4 is your answer. On the second to last one, this is the same concept as the first problem. So I'm going to let you work that one out by yourself. And then on this one, remember that you can always go ahead and multiply your 2 numbers together first. So I'll let you work that one out on your own and finish it in your notes as well. You'll need to pause your video to do that. Okay, here's a little bit more practice. We're going to be rewriting these expressions with positive exponents because, like I already said, you cannot have negative exponents in your answer. So this is 2x to the negative third and y to the third. Something that might be useful to you when we first start doing these problems is to recognize what exponent is on any given number or variable. And I want you to notice right now that this negative 3 that's attached to the x, that negative 3 is not attached to the 2 right here. The 2 is raised to the first power. It's that implied 1 that we've talked about in class. So this will be 2 to the first, x to the negative third, y to the third. Now the only problem with that is that we've got one little negative exponent that we need to move. And I said that anytime you have a negative exponent, you need to change the position of the base within the fraction. And this doesn't even appear to be a fraction, so we'll need to make it 1, so we'll put it over 1. Now the 2 is to the first power. We don't need to write that it's to the first power, so we'll just put 2 as we're simplifying. And the y is already to a positive power, so we'll leave it on top. And then the x to the negative third we'll take to the bottom as x to the third. That's the answer on that one. Now, I'm going to give you a problem. 3 over x to the negative second. And I'm going to tell you that the number one mistake that people always make when they're looking at a problem like this is they want to flip both. So let me just write that down. It is wrong to flip your fraction. And here's why. This 3 is raised to the first power. It's already raised to a positive exponent, so you can leave it where it's at within the fraction. So we'll just write 3. This x to the negative second, the only way you could make it a positive 2 is by bringing it up to the top. So it's just going to be 3x squared. And that's your answer. Now here's a different one. Different kind of problem, but still similar to ones we've gone over. What if you have 5b in parentheses and it's all raised to the negative third power? I have to erase this so I have room to write. Anytime you've got parentheses with an exponent on the outside, you always have to think of it as distributing in the power to both parts. So there's two ways you can do this. You can say, okay, this is 5 to the negative third times b to the negative third. And then you think, okay, they're both negative, so I'm going to have to put them underneath the 1. Then you'll have 5 to the positive 3 and b to the positive 3. And even though 5 to the third is kind of large, you should be working with a calculator. So this should be 1 over 125, because this is 5 times 5 times 5. And then it's b to the third. Now, I said there was another way to do it, and here's what that one is. Let me erase. Sometimes all the options in Algebra 1 leave you confused about which ones you can use and which ones you can't, so I just want to show you both of them. So, 1 over, you're going to put 5b in parentheses, and since we've already put it into a fraction form, this is going to be a positive 3 down here. And from there, you can go ahead and split it up. 1 to the 5/3, b to the third. It looks almost exactly the same because it is almost exactly the same. And you will get exactly the same number as anyone else if they did their steps right, and you did also. So that'll be your answer on that one. Let's do 2 more practice problems, and then we'll call it a day. Alright, let's say you've got c to the negative second over d to the negative third. Now earlier I said you don't want to flip your fraction, and that's because we had a whole number of a 3 on top, and it was already raised to the first power, so it was already a positive power. Well, here we have 2 negative powers, so there's really nothing to do except for to flip them around. So this would be c squared on the bottom and d to the third on top. There's nothing you can reduce or cancel because you're dealing with 2 separate variables. Now this one's a little different. This is our last one for the day. X to the negative 7th times x to the 5th. Anytime you have the same base, you should know what to do by now. You should add the exponents. So when you add that negative 7 plus your 5, you should get x to the negative second. And you might think, okay, I'm done, yay. But you're not done because you have a negative exponent and you're not allowed to have that. So you should know at this point how to flip it. And I've showed you the vocabulary video already. So this should be 1 over x